So, if we want to talk about our hyperbolas in terms of a more general center HK, instead of a point other than the origin, the origin wouldn't be very interesting. For our two arrangements, we have that in the horizontal case, we look at something in form x minus h squared over a squared, where because we have the x and a term first, we're going to be talking about our vertices being a units to the left and right of h, and the foci are c units to the left and right in terms of that h value from the center as well, where we are talking about a transverse axis that is horizontal, and our vertices as described for a very similar shape but in a different position. Similarly, when we look at the vertical arrangement, we have y minus k squared over a squared. So now we're going to be talking about the vertices in terms of position hk plus or minus a, and the foci in terms of h, comma, k plus or minus c, as we have a vertical transverse axis in that case, and the vertical openings. So, to get a better understanding of this, we're going to look at another example where the main thing we're going to be doing with this example is some algebra, because it's nice to have the standard form, but, well, where would the fun be if I only ever gave you the standard form? So for this example, we want to find the equation of the hyperbola 4x squared minus 24x minus 9y squared minus 90y minus 153 equals 0 in standard form, then describe its center and vertices. Well, we've got a lot of fun ahead of us, but what we need to do here is complete the square twice for those x squared and y squared terms so that we can get something like one of these. Where to do that, we want to think in terms of our two mini quadratics as they were. That is, we have 4x squared minus 24x, and that less nice but still workable, minus 9y squared minus 90y, where for the first one, we can pull out, in that case, a 4 to get x squared minus 6x. And from here, we can recognize that if we want to complete the square with that, we're going to need 1/2 of 6 squared. That is, we need a 6 over 2 squared, or, if you prefer, a 9. But, because we pulled out a 4, we're also going to need a 4 with that. So we're going to need to be doing something that adds 36 to both sides. And then similarly on the other term, well, it's not very pretty, but we can factor out a negative 9, and that'll leave us with y squared plus 10y. It's not perfect, but it is better. And we can do the same sort of thing there, where remembering that we're going to be doing something with a negative 9, because that negative 9's hanging around. We'll take the 10 term there, divide out 2 from that, and square it. And we don't get a very pretty number, but 10 halves is 5, square that is 25, multiply 25 by negative 9, and you will get negative 225. So, going back to our equation, we have the 4x squared minus 24x minus 9y squared minus 90y minus 153 equals 0. Bleh. Okay. Well, what we can do is pull the 153 over, because it's just in the way here. And I suppose we could take terms in and out of the 153 if we wanted to, and that might actually work just as well, but let's not worry too much about that, because we can just add and subtract those things and do the addition rather than thinking about the addition ahead of time. Anyway, we're going to pull the 153 over, and we're going to bring in a 36 as well as a negative 225 to make sure that we can pull our parts into the right places. That is, we're going to take a 4x squared minus 24x and add to it that 36 that we wanted. And then we're going to take our 9y squared minus 90y and add to it the negative 225 that it wanted. Then over here, we've got a 153, and because we added 36 to the left, we've got to find a place for that to go on the right, along with a negative 225. Everything we do on one side, we got to do the other. That's the most fundamental rule for algebraic manipulation. You can't do unto one as you wouldn't unto the other. Got to be done. But the nice thing here is now we can talk about these two in terms of completed squares, where we can look at those with our factored out terms as 4 times x minus 3 quantity squared minus 9 times y plus 5 quantity squared. And then on the left side, you got something not so nice. You got a negative 36. So you might think, looking at this, that we have a horizontal arrangement because x is positive in front. But notice, we got a negative 36 here. We want to divide that out to get 1, which means the negative there is going to cancel, and the positive there is going to go away. So you actually have to flip these around a little bit, and putting it in standard form, what we will end up with, well, it's not a very pretty picture, but it's the best we've got, is going to be y plus 5 squared over 4, because we're killing a negative 9 with a negative 36, we got 4 left, minus x minus 3 squared over 9 equals 1, where we're left with a negative 9 here because we're killing a positive 4 with a negative 36, you got negative 9 left. And this from here will tell us all we need to know in terms of our center and our vertices. The center here is going to be the point 3, negative 5. Don't get thrown off by the fact that y is first. That's still k, and k is always the y coordinate, k is always second. So be careful with that. Similarly, for our vertices, notice that our transverse axis is along the vertical because y is first, and because we have a squared equals 4, that means a is equal to 2. So when we're talking about the positions for our vertices, we are going to be taking this center and not messing with the horizontal component of the center because our transverse is vertical. We're moving up and down. Where if we're going to be moving down, we will get 3, negative 7, and along with that, 3, negative 3. Where, to be clear, if we wanted a picture for this, if we wanted to get a sense of what this looks like, I'm not going to go through the steps of generating this graph, but we can see that this is what it would look like. And then if we wanted to get the foci, just for the sake of having them, because they're nice to have sometimes, we would have that c squared is equal to 4 plus 9, so they would be plus and minus root 13 away from the center. Those aren't nice numbers, but they are numbers at the very least. Anyway, we're going to finish this with a quick look at how we can apply these ideas with hyperbolas.